Hi, hello and welcome to ICT lectures. So we want to take a look at blockchain technology and smart contracts. So we are here to actually understand the role of smart contracts or how they can be implemented within a blockchain, right? So you have to understand that smart contract is just some kind of automated contracts. So we have different categories of contracts that people normally engage in. So these are just some form of agreement. But how do we actually uh, visualize or rather implement these particular agreements within a blockchain? So that's what is going to inform the topic of our discussion, right? So what is a smart contract anyway, right? So a smart contract is a computerized transaction, a protocol that executes the terms of a contract. So we can as well replace the word smart with automatic or automated, right? So that at least you get the point. So these are self executing. They can actually self execute when some set of criteria are met. As you can see, there's this diagram here. This diagram shows just some kind of an if statement that if some criteria are met, like uh, if uh, if x is equal to something, then y, and then is being executed, and then also this happens to z. So this is just an example, right? So this particular automated or rather kind of smart contracts can be implemented in different areas. Like for example, if people want to make payments, if you want to purchase buildings, if you want to renew your driving license, we are going to look at different case studies of these particular smart contracts. So to break it down, a smart contract is a computer code. So here is where you place some set of codes that will automatically fire up when a particular criteria is met, right? So they are normally embedded within a blockchain. So you need to have the blockchain platform or any decentralized ledger. We have already mentioned about this particular decentralized ledger. Smart contract also incorporates all or part of written legal agreement. You're going to see two forms of smart contracts, right? Again, it transfers digital assets or vests into this particular kind of otherwise triggered, right, under some determined or rather defined conditions. So ideally, the main key points that you need to understand from the smart contract is that once they are written, they are self-executing and autonomous. Yeah, we normally have an application that we can use to implement the smart contract. We talked about the decentralized app normally used within the Ethereum, right? So ideally when this happens, we can relate this with a kind of robotics within us, some kind of commercial contracts, yeah? You program a robot to execute some services. So that's how a particular smart contract works. Now, smart contracts don't have to be very complex. Remember, they're here to solve the issue of intermediaries or rather centralized authority, right? So we are trying to do away with these. So we have a lot of functions that this particular smart contract need to perform, right? So smart contracts in the ability can handle variable, right, variety of data and automatically be able to execute these particular instructions. So ideally, it should not be complex. Don't think about smart contract as something that just needs to be implemented in a very high-end environment. It's even within our area, right? Just put in mind the kind of engagements or agreements that normally are put in place. Even if you want to purchase something, right, from the shop, right, or you want to purchase a land, or you want to purchase some items. Those are some kind of contracts that we can always implement as smart. So I'll give an example of a smart contract is as follows. You can say, for example, green transfers ownership of securities or other digital assets into the blockchain. Then blue is required to pay $5 US for the assets on a certain date, but for the assets on a certain date, but $8 for the assets if event A occurs prior to that date. So these are some kind of agreement, or rather some kind of procedures that needs to be executed, right? So the smart contract therefore needs to determine whether event A has occurred, all right? So it needs to look at what actually is within the agreement, and it needs to trigger some action for this particular maybe thing to happen. Maybe if payment has been done before a particular date and so on. And therefore, it can conclude by transferring ownership of the securities to Blues. This is just an example. So ideally, what is the importance of a smart contract, right? So smart contracts are legally binding. That's why we need to have different functions, right? The third party writing an agreement with another party, and then we have some legal binding agreements, right? So ideally, it helps us remove manual intervention. Since we are automating processes here, then we don't need to have some manual operations. Smart contracts also enable us to reduce legal costs, right? So it actually removes a lot of legal engagement where you need to go to 3 or 4 lawyers, right? Maybe to have some agreement sealed. It also speeds up the contract creation and execution. The good thing is that once the smart contract has already been developed, you don't need to recreate it again. It can be reused. So if other engagements that requires similar kind of contract, they can always be reused later. So that reduces the contract creation and execution. And of course, it can be automated to transfer funds, not only funds, but other processes that we are going to look at. I've already mentioned the flexibility in contract. Yeah? You can use it in a variety of ways. So those are some of the reasons why we need a particular contract. A contract, I've said, cannot only be implemented within or to transfer funds. It can also be used in other environments, such as the smart city, right? Now, in a smart city, we have different things that needs to be brought together, right? So these things they could be owned or controlled that can produce value. They could be assets, of course, they could be cash, and so on. Then we also need to bring on board the participating entities. It could be government, it could be customer, the people who are participating in this particular agreement. When you consolidate this agreement into some kind of contract, right? We talk about now consolidating the transactions, right? So when you have some engagement between two people, now you can do some kind of transactions. And that's where the term contract comes in. So a contract is just a set of conditions under which transactions can be executed. So you need to have the transaction put in place is when you can be able to have the smart contract. So with the time, we have evolved. So the blockchain has been here for a while. So the first, within the first evolution or the first generation of blockchain, we talk about blockchain 1.0. So this is whereby blockchain was actually developed to transfer funds in the form of bitcoins, right? So blockchain 1.0 dealt with currency. And then we had blockchain 2.0, which actually is what we are talking about. This 2.0 is what has implemented the use of contracts. So ideally, people sat down and discovered we can not only use blockchain to send bitcoins, we can use it to bring on board other functions, and that is the issue of contracts. So with the issue of contracts, we can also deploy smart properties. I've just talked about the smart city. We can also have digital assets, right? And the main technology, right, that really has propelled this particular contracts, or the issue of smart contracts to maybe be used, is what we refer to as Ethereum, right? Or Ethereum, this particular technology. We're going to look at it, right? Then lastly, we have currently the blockchain 3.0. So this one actually implements a lot of applications, right? So we have different technologies, we have artificial intelligence, we have Internet of Things. All these requires the use of blockchain, and the best platform to actually implement this is through the blockchain 3.0. And we have the application, which is Solidity. This is what is normally used to ensure that these particular applications are implemented. Now, as I mentioned, we have two types of contracts. One is deterministic smart contract, right? These are smart contracts, or are smart contract codes that do not depend on outside entities or information from different entities, right? So ideally, this particular smart contracts, they actually work within themselves, within the established environment of that particular code, right? So it's like you can create a code, and that particular code can be used within its own environment, right? So the other ones, in other words, blockchain network facilitating the smart contract has sufficient information to make decisions. So they don't rely on other third parties. Example here is peer-to-peer lottery. So you can see where numbers are held, and then they can be executed, right? Then we have non-deterministic smart contracts. So here is where we rely on third party. So in non-deterministic smart contracts, the network facilitating the smart contract code does not have sufficient information to make decisions. So they need outside party. Usually these particular third parties that bring other useful information that can be used in a particular smart contract are referred to as oracle within this computer science paradigm. So they need to actually ensure that these particular informations can integrate with already established platform of the smart contract. For example, if you're renewing a driving license, the government could be a trusted party. So we could use the government as the oracle that injects additional information about those people, or the digital driving license holders, for instance, right? So those are the two categories of smart contracts. But as we proceed, you realize that they need to work in tandem. And deterministic contract really will not survive without additional information, right? So you realize that mostly the smart contract that is normally implemented is non-deterministic, because we need to add additional information from other third parties. So I think it's the right opportunity for us to be able to understand the various steps of building a smart contract, now that we know what a smart contract is, right? So, but before we look at the steps of building a smart contract, we need to understand that a smart contract is normally constructed based on the underlying blockchain technology. We can't really just have it without the blockchain technology. So you must understand how blockchain is developed, and the operations of blockchain and characteristics of blockchain, right? So when we talk about smart contracts, we have very many applications or other softwares that reside within a blockchain that can help the smart contracts be implemented. As I've mentioned, during as you can see, the first version of blockchain used the Bitcoin. Then the second version is what is using the what? Is using the smart contract. And this smart contract needs to use a particular software, which is Ethereum, right? So the main blockchain software used for smart contract is Ethereum. Now, Ethereum is a separate open source. Actually, it's a very ideal software to use in creating additional functionality of a blockchain, right? So it offers some kind of blockchain-based distributed platform that can help implement the smart contract. Now, Ethereum was founded by this young man. I believe at the time of recording this video, the guy is now 29 years of age, right? So he discovered this Ethereum at the age of 19, and this is just a dropout, just like the likes of Bill Gates. So I think the guy is known as Vitalik Buterin, Russian Canadian. So this person is the one who is making us use Ethereum, right? So anyway, it's good to understand who the founder was. Now, ideally, there's a major difference between Bitcoin and Ethereum. I think in some videos I'll distinguish the differences, right? But ideally, Ethereum is normally preferred when you are implementing the executable code, computer code, or self-executing code. So this is what Bitcoin doesn't have, right? So I can talk about Bitcoin as having just some kind of static transactions that needs to be broadcasted, right? They need to be broadcasted from particular nodes. But for the Ethereum, the smart codes wait for some criteria to be met for this particular execution to happen, right? So this is the Ethereum component. As you can see, these are two nodes, one on the left, right, and you can see they form some kind of, they have some kind of building blocks, right? We have Solidity compiler. We also have Solidity is the main blockchain software, right? So it needs to be implemented. Then we have the Swarm. Swarm are these, we talk about the decentralized hard disks where you can store a huge amount of data. We also have Whisper client technology that allows some kind of, they allow some kind of cryptography. That means that some set of keys to ensure that or the transmission of data happens in a secure way, right? Of course, you can see there's also some kind of backend technology, JavaScript. You can also implement the front end, HTML, CSS, right? So ideally, once you have these, you can now talk about decentralized application, right? So these are just some technologies. So you can say we have P2P networking. Ethereum has some protocols. So these are some of the building blocks, right? And all of these we refer to as decentralized application. So how can you implement one? So you can say a DApp, as the name suggests, is an application that uses smart contracts. So they provide some kind of user friendly interface that you can always associate with smart contracts. Ideally, these can be created as you have seen. The interface can be, you can have a front end and back end. It's just like building a website. So users can use the front end and then developers can use the back end. So it follows some kind of steps. Step one, you need to implement smart contract using the high level language. You have seen JavaScript. They need to be compiled, right? Step two, you need to deploy these contracts, and then you need to develop application that is going to decentralize, so that ensure that people can use the smart contracts. Ideally, we can implement such a technology, or rather the smart contract within a smart city. As you can see, smart city constitutes different applications. You can have smart people, right? You can have smart living, smart government, yeah. So we can bring on board the blockchain. On the left side, you can see we have the normal infrastructure. On the right side, we have the blockchain. So you can see the smart contract implementing the decentralized applications. And you can see the key building blocks or technologies that the blockchain needs to have. Storage, you've talked about that. Data center, the P2P network, it needs internet, and of course the software, right? When you are designing a particular smart contract application, you need to follow 3 stages. Just like any software that you're developing, you need to do some kind of analysis, right? You collect the necessary requirements, identify the entities involved. Like when you're coming up with an agreement, you need to know the parties that are involved, right? Is it the buyer? Is it the seller, right? Also, you need to know the interaction or the relationship between them. Who is the owner of this? Who is giving who to who? And then we have the design stage, right? So you have to model the entities. So for someone who has developed databases, you understand how we use the modeling or the entity modeling, right? So you can transfer these lengthy texts or agreements into some form of variables, right? Then you can go ahead and implement. So implementation will require you to now start using the softwares that you have seen within the decentralized applications. So those are the 3 crucial stages that you need to undergo when you're developing a smart contract. So ideally, smart contracts, as you have seen, can automatize execution, right, of transactions. So you don't really need to be there for whatever you agreed on to happen, right? So once some set of criteria have been met, it self-executes. So this particular diagram, you can see the first part here, as you can see, you need to have the parties agree on a contract, right? Then these particular parties, then the contract defines the set of rules. Then these particular rules are hard-coded into some program, right? Then this particular program goes ahead and is stored within the various nodes, and then the nodes will execute, right? Then the nodes will execute this particular program based on the smart contract procedures, right? So yes, this is how these are the various steps that you're going to look at of how we can create a particular smart contract, right? So as I'd mentioned, smart contracts are useful because they replace some kind of human intervention, intermediaries, right? And they allow automation, automatically, yeah, things to happen. However, we have some underlying risk. If this particular code is tampered with, right, then chances are the agreement might be violated, or the contract might not realize its meaning, right? So we have to take note of that. So this particular implementation of smart contract requires some high level of security. So let's look at step 1 on building a smart contract. Ideally, we need to have 2 or more parties that will form what? The agreement. So the 2 or more parties come together, as you have seen. So they negotiate. They have to write some legal contract. So maybe what you need to understand is that when you are talking about smart contract, we need to also have some kind of human-like contract. Then this human-like contract that is just signed by the participating entities will now be formed and created into some kind of smart contract that are going to be coded, right? So the contract must include the various information, right, based on some specified sets of conditions. So whatever has been agreed within this first step is what is going to be implemented. So step 1, agreement. Step 2, conditions, right? Now, the set of conditions can be internal or external. We have just looked at the 2 types of smart contract, non-deterministic and deterministic, right? So if you talk about internal, this is kind of deterministic, right? So the set of conditions can be internal to the contract, like the manufacture or shipping or delivery of product, schedule dates, expiration. These are the internal information that a particular condition, or rather that a particular contract requires. So there's some set of conditions in a nutshell, right? So step one, we had the agreement. Step two, we have the conditions. Within the conditions also, we have looked at non-deterministic contract. So these are the external parties, right, that normally can play some roles. Either they can be invited or they can invite themselves, whether we like it or not. Like the acts of God, right? Something can just happen where we have stored the server for this particular application. Yeah, maybe there could be earthquake, yeah, some force of majeure, avoided circumstances, like, I mean, weather, so on, right? Financial triggers, like market, movement of, you know how the economic trends normally affect how things are. Changes in legal and financial status, right? And of course, third parties might omit some information, right? Either willingly or unwillingly. Step three is now when we code, right? So we move to coding of this particular smart contract. So here is where Ethereum comes in. So you have to create your smart contract using Ethereum, right? So Ethereum, as you have said, uses the main programming language, which is Solidity. Yeah, Solidity is a high-level language. It's a very easy to use or easy to program a language, right? So that is the third step. So key points here is that we need to understand when coding is that a smart contract will always have two versions, and I've already mentioned it. Human-like, I used to call it human-like contract, right? Human language, this is the one that you meet face to face with the participating actors, right? Then you agreed and you signed some paper. Then the programmers will transform or convert what has been agreed within a paper and place it into a code. That is what we refer to as the machine code version. So it's very, very important to have these two sets. And ideally, it's going to remove some doubts. So if the machine code is not meeting the requirements, we can always fall back to the human language. So the difference between the two, that is the written contract and the smart version. The written contract uses human language, machine uses code. Here all parties of agreement, all parts of agreement are included. But when you're coding, you can't code everything. You have just look at those ones that you can automate. So you have to pick the automated, like the dates and so on, right? The amount, right? And so on. They are freely modifiable in writing. It's very, you can see what you have written. Before you append maybe the legal entity, you can always just modify, right? And then this one can be embedded into a block. This written contract, you can see, is subject to interpretation for them to make sense, right? For the smart version, it cannot be changed. You can only add to. You see, when you change, you have to go back to the written contract and adjust it. So whatever has been agreed from the written contract can only be added to the already implemented code. Therefore, within the fourth step after coding, we now implement our smart contract within the blockchain platform. Implementing simply means you publish this particular code, right? And when you publish, once you have understood how a particular block is formed, yeah, so this particular published set of transactions will need to be verified, right? And the parties will be given the cryptographic keys or rather the private and the public keys, so that they can start maybe engaging within the blockchain. So these are some of the blockchain requirements. So again, if you don't understand how blockchain technology works, kindly review our first tutorial that we talked about blockchain technology. Step 5, after we have implemented our blockchain, as you can see, now it's just to execute, right? So executing means is like telling this particular blockchain to start issuing some kind of transactions. So transactions are triggered based on some set of what? Automated programs that were set within the smart contract. So this is like the live version of a smart contract, right? So by a message sent by a party validated by its, so kind of execution, everything now rolls and takes shape, and the smart contract can be tested whether it works properly. Then lastly, step 6, we can now talk about the recording part, right? So for example, if a sale of property, payment of royalties, all these can be verified and written into a new block in a given particular chain. This is where now the various nodes will get a copy of the newly created ledger, right? So once these particular copies of ledgers have been distributed, or rather broadcasted, then every participating node will have a copy of the smart contract. So I believe that is how we should understand that the smart contract is created. So ideally, you need to look at the version of how you normally create these particular contracts, and how we can create a smart contract. So kindly take note of the 6 steps that is required to build a particular contract. So as you can see from this diagram, this is how nowadays we do, or the traditional way of carrying out some contracts. So I can say the first diagram, as you can see here, Alice wants to buy some land, I believe, and Bob is the seller here, isn't it? So Bob is the seller, Alice is the buyer, right? So what happens when Alice wants to perform this kind of purchase? They need to have some agreement. So there could be a title deed, and we need to have some set of lawyers, we need to have brokers, we need to have insurance. So you realize that all these people, for them to have some form of agreement, first, it's going to take time, a lot of costs is going to be involved, right? By using smart contracts, all these are removed. So once you have just a piece of code which has already been authorized through a legal means, then it can be replicated across all the participating nodes. So we don't really need to go through the different intermediaries, which has been removed by the use of smart contract. So this is the smart contract. Ideally, how we build the smart contract, you don't need to have all the information coded, as you have seen. So a smart contract just uses the executable data. That is what is very, very important, right? Then we also have legal issues that can always come up. And they're kind of legal issues because smart contract is not really being applied in all the environments. So it's very, very important to understand all these legal issues, right? So how does the other side verify that the smart contract version prepared by a party is the same as the written term sheet or agreement for the transaction? So here there's a gap, right? That this particular smart contract, as you can see. Maybe issue with the verification with the participating parties. Actually get the point. So the lawyer, so ideally to remove this, we need to have all those parties again, right? At the start of the building of this particular smart contract, they need to provide the relevant information. So we can't really rely on one party to verify the information that has to be implemented within a smart contract. I hope you see the sense, right? So each party is liable in case there's a problem within the code, right? So that is also an issue, because code could develop some errors, or the person who is coding could have, might have missed some crucial details, right, from the onset. So who is liable in case maybe some amount has been automatically been transferred to the wrong person? Those are the issues anyway. Maybe to bridge these gaps, of course they won't eliminate them, but to bridge them, we can have the sandbox to test first and validate this particular smart contract code, which is really necessary. We know the smart box, which acts like the staging area. Now what happens is that also the participating parties needs to validate what is within the sandbox, right? So they have to be shown how this particular smart contract works. We can also develop some approved smart contract templates that can be shared across multiple parties. This one also could have some errors, but at least it will limit but not eliminate the entire risk, right? So these are some of the issues that can be addressed, right? Use cases of the smart contract, there are quite a number. From this diagram, you can see there are a lot of parties involved, right? And like shipping of cargoes, buyers, insurance, banks. So we can implement smart contracts, as you can see, right, from the seller, buyer. So that when you're shipping containers or you're picking your goods, it should be an automatic process. You get alerts without really bothering where the container is, who shipped it. So you just get automated response. So they can, once you have confirmed you have received your shipment, automatically some kind of money is deducted from your account. So this is what is happening here, right? So you don't need to really have third parties. Yeah, someone calling you see your container is now leaving. No, everything just works on a given system. So ideally, the supply chain is the main beneficiary. So it enables reducing the complexity that is experienced in cross-border manufacturing and distribution of goods, right? A new legal and compliance obligations for supply chain transparency. So what we are seeing here is transparency, right, that the smart contract offers. A coordination of numerous counterparties, like tracking, and of course you can see also we have transparency of the supply chain, right? So when, for example, the containers have been or have some kind of chip, right, like the radio frequency identification, or the various devices have the chips, the sensors can automatically be used to track where a particular cargo is, and if something changes, if someone tampers with the cargo, automatically we get the notification and so on. Insurance also is a beneficiary, like for example the smart automobile insurance policy, right? They can track drivers using sensors, so all data will be continuously and permanently added to the blockchain, right, along every traffic citations. So what happens is that the smart policy automation will increase or decrease based on the data or withdrawals, payments. So it's going to automate the insurance policy. That's what we are saying. So things will just work seamlessly without the third parties. Stocks also, trading and registration of shares, right? Several states, including Delaware. Delaware is currently using this particular blockchain, right, as the official stock ledger. Financial instruments, trade finance. Lastly, also, you can create a simple switch, right? This is for the Internet of Things, the connected devices, right? Like you can say here, users can turn a switch on and off for a certain duration by sending a transaction with a value to the smart contract associated with the switch. So the contract can act as an agreement between the user and the switch. And of course, it can also deduct money. So for a certain duration based on the ether sent to the user, right? So such case can be used in automating solar charging solutions, all right? So ladies and gentlemen, that is the smart contract. We have seen what it is. We have seen how it can be developed, the technologies around the smart contract, and ideally we have finished by looking at the various use cases. All right, thanks.